manager, the Colorado Department of Transportation. So Rob, if you'll introduce yourself and tell us about, what a lot of people are really praising Colorado for being on the, Colorado and Montana and some other places being on the forefront of this new final frontier of the underground. So introduce yourself and take it away, sir.
Thank you, Gavin. Appreciate it. Yeah, Rob Martindale here, coming to you from Colorado. Appreciate the opportunity to discuss some of our program requirements and what we've been up to here in Colorado. Yeah, there's been a lot of discussion around what we're up to and what Montana's up to. There's been it's been a long road to even getting here, but a little bit of background on myself. Again, I'm the utility and railroad program manager out of Denver for CDOT at our headquarters level. Been again with CDOT for a number of years, going on 17 years. My first half of my career was in survey and right-of-way, and then went into the utility engineering side of construction. And so I came out of the private sector before the government, working on construction, and a lot of utility exposure back then as well. But very interesting when I came into the utility engineering side of things, how poorly the agency was, requiring and accepting as-built data. It was really kind of jumbled in paper, and some CAD data was flowing in, but it never made it out of CAD into any sort of database, and very little notification to the end users or the next user of what we spent money on. So my goal at headquarters when I started this process about 4 years ago was to try and find a system or create a system that could capture all this utility data. So the picture you see on the screen, there was a comment, and there's some great questions in that last session, and I'll get to some of those throughout my session. I'll try to answer some of those in detail a little bit more. But this picture is a project that I worked on when I was utility engineer. We had a couple bridges with a lot of utility impacts. So you can see we were installing some new utilities, and we captured all this with CAD or with Trimble data collection, traditional survey data collection, where I'm trying to go. And somebody asked the question about spending about 1% of the design and construction budget on subsurface utility engineering investigation. And so this project was a $100 million project for CDOT. I spent right about $1 million on investigating for Sioux. So that was right in that range of 1%. And then when we had really good success with the project, because we also carried it through with the construction management side of that and collected the as-builts. But the return comes when you have another project or when you're planning another project, because of the as-built data that's associated with this project. And so you'll see that 1% next time go down over time. So you'll have to spend less over time to have your data, as far as investigating for projects. And so again, for CDOT, poor utility records is one of the big things that I'm going to focus on today, and what that cost for us on our civil projects and all the other projects out there are at risk. And it's cost with injuries, with time delays, so there's a lot of different ways to assess the cost and the risk associated with poor utility records. And one of our biggest goals is to provide better records over time and update those records. And so some of this is tied to our legislation that was passed in 2018. You'll see here that I'll talk high level about what our 811 law impacts, but it does impact the utility data and how we manage basically the subsurface utilities and the records as we move forward with our state highway rights of way. And so I'll get into obviously what we're doing and how we're tied to this entire deliverable for utilities. So this picture is utility data on our projects in Denver, right of way, you'll see the purple is our right of way that we have developed. So we're trying to integrate the right of way situation for our utility owners so they can see visually what their expectation is for delivering as-built data within our right of way. Obviously, this is project level data that went outside of our right of way for an expansion project. But nevertheless, the goal here is to identify what our limits are for and the expectations for our utility companies, permittees, pulling permits, where they cross in and out of our right of way, what's expected. We'll go through some of the examples of what CDOT has put together for those requirements and mandates that we have now for utility companies. A lot of discussion, I think, well, in the last session about, a one-stop shop, and I spent several years trying to find a one-stop shop for a database and a mobile application that could process all the different types of data. And if you look at this graphic, when we look at all the survey data that's out there, the SUE data that's coming in, old GIS records or even current GIS records on whatever's out there, CAD files and utility relocations, new installations, one call locates, and in future projects, this is kind of what we've, seen as well from CDOT's perspective, that we need a place for all of this data to funnel into and then publish, to the end users out in the field or in the office. And so we look at that Transparent Earth Point Man package for CDOT was a good solution because of how we operate with a lot of the legacy systems we have, and trying to find a solution or build one. And we looked at that as well, trying to build one internally, and it was really cost prohibitive, and the time it would take to develop an internal process for this, or internal hardware and process, was going to be much heavier lift than what we could take on. So that's why we looked at off-the-shelf solutions for Colorado. And so you'll see our process flow over here on the right, that we're working to implement the roles and responsibilities, procedures, policies, and structure of the process for collecting and combining and sharing 3D utility data. And the framework really comes with having the proper tools for that, and then again proper rules and regulations to implement that even further. And so when you look at Transparent Earth and Point Man for Colorado, we look at it really as a live subsurface utility engineering file. The existing and new utilities, again, the CAD data, we have drone imagery, we have one call and excavation notifications, which a lot of states can tell you that the one call excavation notifications is really a place where we find a lot of discrepancy between one call locates for excavation and the amount of data we have supplied to the contractors in our utility plans for construction. There's differences there. Our goal with this process is to have a one-to-one relationship where our construction plans and the excavation locates match perfectly. I know that's unicorns and rainbows, but we really want to see that in the end, where our records are that good that when we work on a pre-construction package, the excavator goes out and they're looking at it with the mobile app, or they're putting it in the cab of their excavator, that they can rely on the fact that the paint on the ground is the same as what's being delivered to them electronically. And so it's a heavy lift, but that's the goal, is that the records become very, very accurate horizontally and vertically. And so again, this is how Colorado's taking this on. So it takes the mobile app, it takes high accuracy GNSS receivers like the Trimble R10, the integration to make it simple enough to use for the non-surveyor, and so that's part of the goal. As a surveyor myself, I know sometimes how complicated it can be to survey with all this technology when things are not working, how to troubleshoot all this stuff. And so that's still in here, but the startup and the integration and the corrections that we were talking about with DA1 Trimble receivers and catalyst correction systems, all that stuff, we want to make that as seamless as possible so that utility companies, their contractors, third-party inspectors, all of these folks that are working in our right-of-way have access to this technology, and it's user-friendly enough that they can see that they should be collecting data at a higher accuracy just based on the simple integration. And so that's what this is intended to reflect, is that you can tie this GPS receiver, RTK receiver to the mobile side much easier. And so part of what I really like about the system is the survey record capture. And so Paige spoke about that quite a bit, and this is just one example of some data that we collected on an as-built of a railroad project. And so new construction concrete panels went in on this crossing. We were able to collect the final elevation and grade because there was a little bit of change in the tracks. It actually came up a little bit, and so our approach slabs into the concrete panels were rough. And so we were able to go out and actually collect down to centimeter level and see how much the pads had changed versus what our approach, and then we were able to tell our maintenance folks how far the approach paving needed to go back in order to smooth out that crossing. And so that's just an as-built on railroad side of things. Same thing with utilities, but the slide on the right is also one of the nuances that we like for our mobile app, which was survey information that comes in through the settings side of things. So if you look at the GPS portion of this down at the bottom, you'll see that there's some projections that are built into the library. So you can get to NAT 83 2011 is built into there. The geoid models are built into there for those that are wondering about the geoid models in the US. Those give us ground corrected elevations. So we're working off of orthometric heights, and so that's important for us to relate back to our old records, because everything that we've done in the past is orthometric elevation type data. And so one of the other things that's really unique that we like here in Colorado is site calibration. You'll see that there is you could build a site-specific calibration into your project. And so if you want your northing easting elevation built in so that it's corrected to your project level coordinates, then you can enter that data into here, and you'll have a site where your output is lat long northing easting elevation on project control. And that's a very, very good situation for us when it comes to migrating into our CAD environment. Then it seamlessly drops into the right northing easting location in reference to the CAD files. And then the correction or diff down there is what we were talking about earlier, as far as being able to get into an N-trip system or a correction-based system for differential correction. You can get into that there, and then you have the ability to correct based on the different types of systems you're trying to log into. So a lot of survey GPS stuff, but this is some of the stuff that we really look to for the GPS or GIS survey kind of hybrid system that I continue to talk about. We're not fully on the GPS side, we're not fully survey, but we're somewhere in this hybrid of survey GPS. So it's more like high accuracy GIS world. And so there was a lot of discussion about database, and this is the GIS side of it that's important to us, because we're able to grab the metadata, from the data that is collected in the field. So if you look at this record, it just shows simply that the owner of this water line is the city of Denver. It's an 8-inch PVC. All your GIS applications will do the same thing. One of the things that we really like at CDOT, if you look at this and you can see it well enough, there's a code in there, 4710. That's a survey code that's built into a data dictionary, custom data dictionary, that allows that code to migrate into MicroStation for us, and it will actually add the waterline symbology that's built into our MicroStation world. So, but more than that, we can also bring in shape files into our MicroStation environment for 3D modeling and flash detection, and that's where having northing, easting, and elevation tied to that is important to CDOT. So with that, that's some of the background on CDOT and what our expectations, the hardware and software that we've selected. ProStar, their solution with Point Man and Transparent Earth. So how do we leverage all this within our right of way? We know that we have the tools. We now have we now have to find a way to mandate or train or whatever we're going to do to get this out there so that it's leveraged. And that all starts with the utility permits on our side. Every utility installation within our highway right-of-way starts with the utility permit. And so that permit for us means that we need to make sure that we have required documentation built into our code, that whenever that permit is executed, the contract between CDOT and the utility owner is clear that they are to provide us as constructed plans, as built, electronic as built, and what that expectation is. And so we have that in our system, in our utility accommodation code, and it's built into our permit terms and conditions and other notifications through the permit. And I'll show you some examples of those here in just a second. One of the other things that's important for CDOT to follow, that we feel anyway, is this is a new standard coming out of ASCE, American Society of Civil Engineers, the Construction Institute, and the Utility Engineering and Survey Institute have developed a standard guideline for recording and exchanging utility infrastructure data, or an as-installed condition. And so this document for us is very important because it standardizes the expectation of what the as-built needs to be and what it needs to look like. And so there was a lot of committee members from a wide range, as you can see, of backgrounds and experience that provided the guidance into this document. And for me, I really think it's good information to use. And so we are. In our terms and conditions, if you we have come to where we provide the expectation to the utility companies and their contractors, or whatever it might be, the third-party inspectors that are working on these projects for the utility companies. What is the expectation for data collection? So the graph you can see on the left, it's for example, if it's a HDD installation, we're going to have you collect the right-of-way line, edge of pavement, and then subsequently we're going to need the bore log to adjust the surface elevations down to the wherever it's taken, probably center of the bore. So same with an auger bore. If you're in the bore pit and you're in the receiving pit, here's the expectation for what we're looking for, and so that's provided to the permittee. And then this is also part of our as constructed requirements for the utility companies, and it's the as constructed requirements for projections and coordinate systems, positional accuracy specification. We also provide the list of equipment that we will accept for pairing with the Point Man mobile app. Now for CDOT, we provide the Point Man mobile app free of charge to those that are in our pulling a permit from CDOT. We provide in this as constructed guidance a link to where they sign up and a short video that shows them kind of how to get started, get logged into the CDOT environment. I think that's one thing to really note, that our CDOT environment, once they're signed up and logged in, when they're collecting data in that environment, it all streams through that user ID into our environment. So there's a lot less manual effort, almost zero, that has to be done when it comes to supplying their observations into our database. So And then what's helpful for us is when we require the personal ID, we can see who it came from. So if, for example, if you're an energy company and you have 6 subcontractors or prime contractors working on a project, all of those that are going to be using the mobile application, all the users need an ID and login. So, we're up to almost 200 users in our system right now with all these contractors that are working for the utility companies, which for us is really important because I can really drill down to and search through the database in Transparent Earth who provided the data, when, and how. So, so you can see we're requiring a certain type of projection, certain type of orthometric elevation correction for elevations, and then the positional accuracy table, which I'll show on the next slide, which comes, I'll get to that in a second. But then on the right, you can see the equipment that we suggest that needs to be paired with PointMan for centimeter accuracy. And so the table here that you see is provided by ASCE, that standard guideline for recording and exchanging utility infrastructure data. This is published in their document as far as what the positional accuracy level is on the left, and then in feet down the middle. So if we're asking for positional accuracy of 1 and 2, no less than that, then we're expecting a 2/10 of a foot. You have to excuse me, I'm next to a train track. 2/10 of a foot accuracy for our positions. And what's different in Colorado is we don't require the certification by a PE or a PLS for our data. So what we would rather see is the positional accuracy tied to the observation and the survey record that's being generated out of PointMan and that position survey record that you guys saw earlier. And so once that's provided, maybe it's a 3 or a 4. For us, we're just looking for the quality of the record that's in our system, and can we use it and leverage it for design later on, or do we need to spend money to update that record to a higher level of accuracy? And I'll get to why that's important based on our SUE law here in just a little bit. So when it comes to permitting, this is an example of why we're pushing for more of this data to come in through our new system. I mean, previously a permitted design looked like this. It'd come in. This is just a simple telecom. They identified where they were going to put this line in our right-of-way, stamped it, certified it, provided us an electronic PDF version of it. Said, yep, this is where it's at. We're good with that. We're going to provide you also with the electronic GIS file. So they provided a shape file. The red line is what we were given by the utility company. And lo and behold, we had some issues with that. So we before we'd implemented data collection with an inspector and third-party inspector, and we end up with CAD data that looks like this that never made it into our database, and so we struggled with some of our as-builts in the past. And so what we've inspected, our inspectors now are out in the field rather than the old method of just the data collector and the survey antenna. It's more interactive now. We're using the mobile app, and we're using the GNSS receiver. But then, as you can barely see this, but there's a blue line that's showing up now that was out in the field when the CDOT inspector went out. They noticed a different line of disturbance in this area. And so they surveyed it in, and questions came up about where it was actually installed. And lo and behold, the blue line is where the telecom line actually physically put the line in the field. It was never conveyed back to the office that it needed to be corrected. So what had happened was the designer pushed out the red design, said, yeah, nothing changed in the field, which everybody knows, is almost unrealistic. We know things always change in the field. So So this gives us more leverage in the field to see. So we're actually now asking for the design level electronic files to be provided so that they can be published to the mobile side, and our inspectors can then adjust, or on the fly they can resurvey and start to document where things are changing through construction observation. And so this is just an example of our construction observation techniques as far as when a new utility is installed. On the left-hand side of the screen is just the as-built of the new gas line that was installed. In the survey record, you'll see that there it is. It was surveyed with an R10 Trimble unit, RTK fixed information. In the middle, you'll see a shot of just a dot. It's hard to see the dot, but it's kind of highlighted in blue. And then down below, there's a record that's being selected. And so that's where we embed the utility permit information into the project geospatially. So geospatially, it's out there with the contractor, with third parties and third-party inspectors and everybody else. And then you can see on the right-hand side, we have a link to it. And within the mobile app, you can pull up the permit, the as constructed requirements, the typical information as far as what needs to be collected. Also in there is the plans that were provided to us by the utility company as their design. And so we can look at that. If something's starting to vary with our construction inspection, we can refer back to the plans that were provided, and then bring up more questions if needed. But furthermore, we can also document it with our construction and inspection form that's also embedded into the mobile app. So we have a daily observation form with photos and sketches that are embedded within that form. And so the daily logs are extremely important to document how the installation was going, what happened from day to day, to capture a good record of everything. And then what's nice is it's geospatially referenced. All this is in there for future reference, whether it's mobile or office. It is captured there. And on the office side in Transparent Earth, we can search quickly through the database and see either by user or by date or whatever it might be. So when we look at the subsurface utility engineering side of things for CDOT, this is on the pre-construction side. You can see that our requirements are pretty specific, that we have a SUE notification that goes out. Our engineers of record have to be competent in utility construction and survey enough and geophysics, and they have to then work to provide a quality level B product based on ASC 38 standards, whether that's 02 or 3820, doesn't matter. Our law is specific to 38, doesn't differentiate. It's whatever's the current version. And so yes, a quality level B package has to be attempted unless there's some sort of rationale, reasonable rationale why they couldn't get there. And what we see, that reasonable rationale from our certifications that we're seeing, is because of poor quality records. The records that they start with, it's almost impossible sometimes to use every geophysical tool in the book to even find it. And so there is issues with the records, and that's again where we're focused on providing records for our SUE vendors in order for them to achieve a higher quality level for our future projects. One nuance with our Colorado law is that all underground utilities must be electronically locatable when installed. This is a good thing, that even laterals, so anything going in the ground has to be electronically locatable. There's been some guidance put out by our safety commission, which is new, that 15-member safety commission that implements rule making based on the law. So they've defined electronically locatable. I'm also working with that safety commission to define survey accuracy as tolerances for electronically locatable, as well as tracer wire, marker balls, other things. So that's still ongoing. Our Sioux vendors really seem to like the ability to publish Sioux information right into Transparent Earth, the Point Man, and the EM locator and the GPS antenna. Paige spoke to that. This is some actual data on a intersection project that was published directly from the Sioux investigation into our system. The record on the right-hand side spells out all the survey information, but also the EM locator information and how they came to a quality level B designation, which is on there. And so some Sioux vendors will not designate it in the field. They'll go back and compare it to records, and then they'll assign it later. But that can still come back into our system, and we still have snapshot in time for what that subsurface utility data look like. And so again, on the mobile app side, this is same data, just out in the field if need be. Paige Tucker touched on the 811 integration. CDOT really finds a lot of value in this. In fact, I was just meeting with a telecom last week about how they want to mandate their locate vendors. When the one call tickets come in, they're going to track them through Point Man. When they do their locates, they're going to use the EM locator paired with a GPS antenna to capture that data and provide it into their system, so they start capturing better records, and then we can share that data. So there's that collaboration that's quite huge between the utility companies, their locators, the agency, and this again leveraging the technology. So this is another example of the locate ticket, and then our locate form that allows those that are trying to investigate that ticket the access into and pull the data out of the one call database and auto-populates the form. So getting back to what CDOT's trying to accomplish, from large installations to small installations, we're going to leverage this technology to capture all the data, one location, one mobile device that will be out, in the field, leveraging that mobile application and our database. Over time, we do feel like that our records funneling into one location will be advantageous, and our costs coming down for Sioux investigations will offset the cost of paying for software like this. So with that, I appreciate it again, the time today to showcase what Colorado's up to, and we'll take questions.
Yeah, thank you, Rob, for giving our lunchtime keynote on what lies beneath. I'm always impressed with what's going on in Colorado. We're working on this in our state, but we got questions from the attendees here. One is a scenario. During the layout of a new utility or construction of a new section of highway in a pre-populated or high area with, say, a high potential density of subsurface utilities, what percentage of investment goes into locating the subsurface utilities typically, and how much would this vary from, say, a greenfield project?
Well, that's a really tough question, but I think when you look at how Colorado's breaking this out, we look at pre-construction and construction. So our pre-construction budget for Sioux subsurface utility investigation, we set a budget between 0.5% and 3% actually is where we're seeing our subsurface utility investigation budget based on scope of work. So we develop our plans, put it out to bid, and then we also roll into our construction management cycle. That is another budget item to where we have construction management, utility inspection, as-builting. That's just for CDOT, projects. The utility permitting side is obviously different, but we have two ways of approaching the data collection, but the cost associated with Sioux, again, is within the national range averages, and then we have a whole nother range for construction management that we budget for early on to try and capture the data. So it's really a utility process management life cycle. We start with Sioux, we keep the Sioux going all the way through construction, and then it circles back around, because a lot of times Sioux I think people forget that Sioux needs to stay live all the way through construction until you're done your as-built. So, so there is a budget for all of that to happen so that it does come back full circle.
Okay, so you have to budget for, pre-construction, design phase, and also the as-built at the end, so that has to get budgeted.
Correct. Yep.
Okay, so a question about technology. To what extent is LiDAR being used to document location utilities during when they're being constructed?
For us, we're not. I'd say it's a low percentage for us right now using LiDAR to document utilities as they're being installed. We're more traditional when we want to, we're having boots on the ground do the collection at this point in time.
Okay. A question about, so you've worked with ProStar GeoCorp for the app. How much is it customized for your own uses?
Honestly, we did a few customizations to it. Our data dictionary wanted our survey codes in there. We wanted a few custom forms like construction observation form, the locate form. Trying to think of a couple others, but for the most part, it's really set up to it's almost all there. I mean, there is a few things that you have to customize for your own personal needs, but the nice thing about it, there's a lot of scalability and flexibility built into it.
Okay. Here's a question. Do all utilities and telecoms in Colorado provide data to CDOT Transparent Earth? I mean, does it support protection measures such as restrictions on dimensions of polygon queries? How is there's the telecoms that don't want their competitors to see the data. So there's I don't know, nebulous question here about the security issues and data sharing.
Yeah, there's that's a great question. We get it all the time. We get it from utility companies a lot. In fact, they worry that there's something that they need to keep under wraps. But yeah, there's a lot of flexibility in the permissions to just allow people to see certain things, allow them to edit or view certain things, and so there's some good securities in there now. I think there's some newer ones coming out in the future that will lock specific users out from seeing others. At this time, we kind of hide a lot of the data that we want, not hide it, but we do lock out a certain amount of layers to some of the users that are out there so that they can't see their competitors' stuff. And so there is a lot of that built into the system. There's some things that we've seen that are being addressed that I think will make it even stronger here in the near future.
Okay, and then here's a question about liability. So the attendee asked, it appears the data is being collected by non-licensees. I guess assumption non-licensed surveyors or engineers.
Mm-hmm.
Does the end user agree to use it at their own peril or risk? Is there zero liability by all parties if there's a utility hit?
Oh, there's
Yeah.
I mean, there's a lot to that question, but the function we're trying to emulate is high accuracy GIS data collection. We're not trying to sell it as survey. It's not being certified by surveyors, so it's not a survey, and we get that. But we are capturing a survey record, or a record from the GNSS receiver that gives us an idea of how well the observation was collected, and that's important. But as far as the liability of the data, there's two things. We have SUE certification in our state that requires a professional engineer to certify. So we certify their work on utility investigation. So a lot of that liability for our projects is taken on by a professional engineer of record. And then on the contractor side, they're bound by state law for excavation locates, and so they're not immune to anything that they're given. You know, they're given, even though they're given all this information, it's all really all it is. It's information, but they still have their due diligence to take the information and investigate it further before they excavate and through their excavation locates. And so, again, at some point, our SU data and the excavation locate data, we hope matches up identical, that what they see in the field is what's being produced in the office. And, you know, that's our goal eventually, is to really have super accurate records out in the field. But yeah, I think the liability is, you know, again, I think it falls on two entities or professionals. You have the contractor and you have professional engineers.
Okay, so it looks like you're through the design and construction process and the permitting process. You've got, you know, you've got leverage over all the parties. You know, I'm not saying you're lording over them, but there's a mechanism whereby you can have them use this system to feed the data and to, you know, read the data from the system. So questions from users, several questions came in around about the learning curve for the typical end user. You've got a, you know, you've got a utility going to put in a line, and their crew is going to map this for you. You got learning curve issues, or is it pretty straightforward?
No, there's absolutely a learning curve. And in fact, last week when I met with the telecom company and their prime contractor that does 90% of their installs, you know, just going through the process of connecting, you know, GPS equipment, GNSS equipment to the mobile app, and you know, they were standing under a tree and they were like, well, we're not getting the accuracies, you know, just those little things of, hey, you need to get a little bit clearer sky and do these things in this process. It is, but within a couple hours, they were starting to kind of get the flow and how to collect new points and lines and segments. And then we've discussed with our end users that we're setting up a virtual town hall every month. We're going to get together all of those that are registered in our system. We'll send out an email notification that we're going to have an end user meeting and come together once a month and go through, you know, walk through some of the issues they're having, or, you know, that's just monthly, but we still have access to a lot of different training. And we have, again, like Frontier Precision's doing the GNSS point man integration. So when they sell equipment to these end users, they're supporting any of that effort. You know, ProStar supporting the point man questions and issues, and CDOT supporting signing people up. And so that it takes a village to get these folks trained. But the more we get trained, the more feedback we get. It's positive, and in fact, the telecom last week has very limited technology that they're leveraging right now, and they thanked us for mandating this, because now they went to their management and said, CDOT's forcing our hand. We have to use this system. And so now they feel like they actually will use that system for themselves, for their own records that they're lacking, and for their locating vendor that's struggling to provide decent locates. And so it's starting to kind of wave, you know, this wave's starting to migrate along, and it's looking a lot more positive than anything. So
Fantastic. I actually got to talk to one of the end users, and pardon this characterization, but he said it was slicker than snail snot on a doorknob. So,
well, you can't summarize it any better than that.
There you go. No, I really, you know, we got to applaud you guys for what guys and gals for what you've done there in Colorado. It's a good model for other states. And thank you again for presenting, and Paige as well, to show this, you know, solution in case study, statewide case study.